Hello, good morning. Today we will be studying about different types of rotors used in centrifuges. So let me share with you. Different types of rotors. Consider rotors coming four varieties. There is a fixed angle rotors, vertical plate rotors, swinging bucket rotors, and zonal rotors. The fixed angle rotors, these rotors have holes within their body, and one can slide the centrifuge tubes within these holes. Series of holes are at an angle between 14 to 40 degrees Celsius to the vertical. The tubes and the solution within also take the same angle. Under centrifugal field, the particles move radially outwards, travel only a short distance before they strike the hole. The particles then slide down the hole and the pellet is formed at the outermost point of the tube. This sliding down makes the sedimentation quicker, which is known as the wall effect. However, there is a severe disadvantage that the particles differing highly in their sedimentation characteristics can only be resolved in these rotors. Particles that do not differ much in their sedimentation behavior are not resolved. So this is a picture of the fixed angle one. So here you can see the centrifugal field is acting in the horizontal direction, and the axis of rotation you can see in the vertical direction over here, and how it is angled also we can see. So the figure A shows it was like a cross section on the typical fixed angle rotor which we saw earlier. So now this figure B represents to be split with a gradient and placed in the rotor. No centrifugal force is applied now. Okay, C, the figure C shows the application of centrifugal force leads to reorientation of the sample and the gradient. And D shows that the sample components are separating, and E, the figure B shows that gradient reorients as the rotor stops. So in the case of vertical tube rotors, these rotors also have holes within their body to slide the centrifuge tube. However, these holes slide parallel to the rotor shaft and not in an angle similar to that of the fixed angle one. As the rotor accelerates and centrifugal field is applied, the solution within the tube reorients to 90 degrees here, and this reorientation makes it lie perpendicular to the axis of rotation. As a rotor decelerates, the solution orients back to the original position. So that is what is shown over here, the axis of rotation and centrifugal field and the picture of the fixed angle rotor. So here we can see in the figure B when the centrifugal force is applied, and we see on this you can see when the centrifugation happens and finally how the separation is happening. Sedimentation in these rotors refers across the diameter of the tube. The particles thus have to traverse the shortest possible distance. The sedimentation is quicker than the other rotors. Moreover, the tubes lie at the edge of the rotor, and this makes the rotations per minute quite large and RCF at its minimum, and is more than what is possible in any other rotor. This is another reason why separated impulse rotors are quicker. The pelleted inside rotors will be deposited all along the outer wall of the tube, and this can be a disadvantage as the pellet may fall back in the solution at the end of the centrifugation. Even if it doesn't fall back, it may not be easy to reconstitute the whole picture, and some loss of the mean may be inevitable. The vertical rotor refers to rotation component where the main shaft is oriented vertically with perpendicular to the ground, and its working principle depends on whether it is used in a centrifugation application or a power generation application. Okay. The vertical rotors in centrifugation particularly are designed for rapid sedimentation and high resolution separations. And their tube positions are placed in slots parallel to the motor axis, we have seen earlier. And separation mechanism, as the rotor space particles within the sample move perpendicularly to the axis of rotation, and outcome is that it results in faster run times and high resolution, and a shorter path length in these centrifuges. This results in fastest possible separation also. So that's all for today. Thank you.